2.3, solving radicals. The catch with solving radicals is, what can we not have under a radical sign? We can't have negatives. Can we have a 0? Can we take the square root of 0? Square root of 0 is 0, so that's fine, right? Logs, you can't have a 0 beside, and logs, you can't have a negative, we agree. But radicals, we can have 0. We just can't have negatives underneath, correct? And really, in the past, we've been fine. Is it blinking? Yep. Okay, really, in the past, we've been fine because whenever we've solved radicals, we've had just numbers underneath, no variables really, correct? But the moment you have a variable under a radical, you have to state a restriction for that variable, because we can't have anything be filled in for that variable that's going to cause you to have a negative underneath. We agree? So in this case, we have 12 minus something. So let's figure it out. If it was 11, would we be okay? 12 minus 11, square root of 1, we're good. If it was negative 4, 12 minus a minus 4, 16, still good. So negative numbers will work. Because they're going to turn positive, correct? 11 was okay. What about 12? 12 minus 12? 0. Can we take square root of 0? Still good. What about 13? 12 minus 13? Negative 1. Can we take square root of negative 1? No. So where does this one start? Where does our issues begin? When x is what? Greater than 12. If x is greater than 12, we run into problems. If it's 12.1, we'd have 12 minus 12.1, which would be negative 0.1. We can't take square root of that, correct? So when we have linears under the radical, it's actually really easy to do. You just go 12 minus x has to be greater than 0. And then you minus 12. And we'd have negative x has to be greater than negative 12. And when you divide by a negative, what happens with an inequality? Your inequality symbol flips. So we'd actually get x has to be less than 12, which is true. What can we also have in this case, though? We can have equal signs, correct? Because it can equal 0. We agree? Another way we can figure out what the values are going to be is we can type this radical into our calculator, or even just the equation into the calculator. So we'll type the equation that's under the radical into the calculator first. It was 12 minus x. We agree? Let's do. So I'm going to go 12 minus x into my calculator, and I'm going to press graph. And I'm going to move this out of my way. And I'm going to make my x max be 20. So where does that graph start giving me negative values? Bless you. When x is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. At 12, I'm still okay. But after 12, what happens? I start getting negative answers. So where is x good? X is good when it's less than 12. We agree? Let's put the radical in and see. So not the whole entire equation. I don't want the entire equation. I want just where I have issues. The only issue I have is the radical, right? The rest are like x's and 4s or whatever, 7s. Those are fine. So if I go square root 12 minus x, and I press graph, the graph only exists at less than 12. We agree? 2 ways to check what your restrictions are. Does that make sense? Okay. So the first thing we'll always do when we're solving is we're going to state restrictions first. So our restriction is that x has to be less than or equal to 12. So if I get an answer that is greater than 12, it's out. It's extraneous, right? The other thing is you actually have to check your answers and see if they work. So whenever you're solving, really, because you have 6 hours on a diploma that they set to be done in 2.5, I would say you have time to check. I'm just saying, okay? The diploma is literally set to be done at 2.5 hours. You have 6. If you're like, I just ran out of time, I just don't feel like I had time to do the checking, you were lying. You wanted to leave early, you were tired. I get it. I get it. 30% of your mark though, so I would just work through that tired and stay an extra few minutes, okay? So whenever I give you a solved question or the diploma gives you a solved question, you can check your answers 2 different ways, correct? You can plug back into the original, the typed version, the version you have not touched, the version that the diploma wrote for you. Okay, it's in typed bold letters. It's not written in pencil or pen by you, just so you know. So the original is in the actual question. Okay, you can take your x value and you can plug it back in and see if left side equals right side. We agree? What's the other way you can check? What's the other way you can check? Yeah, y1, y2. Okay? You should not walk away from a question that says solve and not know if you got it right on that diploma. You should be able to walk away and say, I got those ones for sure correct. Okay? The only way you wouldn't know for sure if you got it correct is if they ask for an extraneous route. But if they ask for an extraneous route, you should be able to check because it's going to be the answer that doesn't exist when you check it. Or when you check it, it doesn't work. So either way, you're still checking it. Okay? Whenever it says solve, you should be checking your answers. Okay. This one says solve. So at the very end, we're going to do check, and we're going to see if left side equals right side every single time. Okay. So how do we solve a radical? Well, my biggest issue when we solved rationals was that we had fractions. We wanted to get rid of the fractions because that was the ugly part, right? Once we got rid of the fractions, we were back to grade 10 and 11 math. We agree? What's the part in here that's ugly? The radical symbol. If we can get rid of that, we're back to grade 10 and 11 math. Life is good. Okay? How can we get rid of a radical? Square it, right? If I square it right now, if I square this entire side, that's some foiling with radicals. Does that look like fun at all? No, that looks awful. So what I'm going to do first for my first step is, what would make it less awful? Move that 4 over and get the radical by itself. Because if I have a radical by itself and I square a radical, it just goes away, right? No foiling, no factoring, no nothing. Let's try that. So our first step is to get the radical by itself. I should say isolate the radical. On one side. So I'm going to subtract the 4. And I'm going to get 3 equals square root 12 minus x. And now squaring it would actually be helpful. Because when you square square root, what happens? It's gone. So now I have 9 equals 12 minus x, and I have grade 10 math. Grade 8, 9 math. What do I do? Subtract the 12. Negative 3 equals negative x. Then what? And what should I always do at the end? Check. So there's 2 ways I can check this, my calculator and by hand. I'm going to check it by hand. I'm also going to see, hey, does it work with my restrictions? My restrictions say x has to be less than or equal to 12. Is 3 at least there? Yes. So we have a good chance that it's going to work. But we still have to check it. So we check it into the original. We don't check it into this blue equation that I made because I touched that. And if I touch something, you always hope that it turns to gold, but sometimes it turns to rubbish. Rubbish. I've never got to use that word, rubbish, but we did. So we're going to use the red equation because we didn't touch that. So check. I'm going to check x equals 3 by plugging into left and right and seeing if they equal. So 7 equals square root of 12 minus 3 plus 4. 7 equals the square root of 9 plus 4. 7 equals 3 plus 4. And now I'm getting happy because 7 equals 7. And I'm good, and I'm good. Yay. Could I y1, y2 it? Absolutely. Second choice 5, enter, 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 and you will get 3. Okay? Now you're like, well, it must get harder because this is not, we know, it does. It gets harder. But not like cray-cray hard, just a little harder. This is actually a really nice lesson. Okay? So let's try it out. Example 2. Solve. We didn't solve a quadratic, did we? Probably going to have to. It's just how we roll, okay? So try this one out on your own. Square root x plus 5 equals square root x plus 5 equals x plus 3. I want you to solve it, and I want you to state restrictions. See how you do. So, for this one, our restriction is going to be x has to be greater than or equal to -5. So we have square root of x plus 5, and we're going to square it, equals x plus 3, and we're going to square it. And then we're going to get x plus 5 equals, and whenever we see this on the diploma, we don't care. We don't care it has a 2 out there. We're going to cross that 2 off. And we're going to write x plus 3 again, because that's what it means. We are not going to put x squared plus 9, because they will have the answer to that, and that is mean. Mean. However, you're the one who was wrong, so it's not really mean. It's just you're wrong. That's a problem. So then we have x squared plus 6x plus 9. And what do we do? Oh, we're back to grade 11 quadratics that people hated. But now they don't hate anymore because they've had to do it in every unit. Woohoo! So what do we do? Equal to 0 and factor a quadratic formula. If you could go back to grade 11 and redo quadratics, you'd be like, boom, I got this. Let me add this unit. No problem. Okay. Minus x minus 5, boom, boom. 0 equals x squared plus 5x plus 4. Not even decomp, guys. Oh, can't get much better than this. So we go x plus 1, x plus 4. You also did this last year. Remember, this was a hard lesson. X equals -1, x equals -4. This is all from last year. The whole whammy. Okay. So what do we have to remember to do at the end? Check into our original. So I'm going to check x equals -1. So I'm going to go square root of -1 plus 5 equals -1 plus 3. We get square root of 4 equals 2. 2 equals 2. Happiness. Woo. And then I'm going to go x equals -4. Try that one out. -4 plus 5 equals -4 plus 3. Square root of 1 equals -1. And then you're like, oh, I must have messed up. 1 equals 1. We're good. No, you didn't mess up. It doesn't work. It's bad. It's bad news bears. Trust in yourself. Believe in yourself. Don't change it to be like it has to work because I just messed up and it's my math. No, it's not. It's wrong. Okay? All right. The next one I'm going to have you guys do. We're going to solve and we're going to state restrictions. This is the big kahuna. Solve and state restrictions. How could I make it harder? This one we had to solve a quadratic. Decomp I could make harder, yeah. How come it's not what? Because the square root was already there. So if the square root was already there, we take whatever sign it is, right? We only do plus or minus if we're like doing x squared equals 1 and we're solving it, then we get positive, negative. If the square root symbol is there already, it already has a sign. It exists. Okay? Good question. Okay. Solve and state restrictions. So I could do decomp. That's a little harder. However, that's not where I was going. What could I put under a radical that would make it harder? Cha-cha-cha. Cha-cha-cha. A fraction could make it harder. A log could for sure, but why would we do that? Cha-cha-cha. Cha-cha-cha. They could do that on the diploma. Oh, you could put trig under there, but that is not where I'm going. Those would make it harder. You are correct. A quadratic. Good answer, guys. I could put a quadratic. You read my mind. You're all so smart. So square root 3x squared minus 5. You guys were really going vicious, like sines and logs and trig. And why don't we throw a proof under a radical? I'm sure that would be better. So 3x squared minus 5 equals x plus 4. So I'm going to have you undo that one in a second. It's actually not ridiculously hard by any means. However, the restriction is a bit harder, right? Because it's not just linear restrictions. So what did we do to figure out the restriction? Well, we typed what was underneath the radical. We got our little line, and whatever part of that little line was below the x-axis was an issue, right? We can do the same thing. We'll type in 3x squared minus 5, though, this time. So clear, clear. 3x squared minus 5. So this is my issue, right? Anything to the left of this x-intercept, so if we went x is less than or equal to this, or we went x is greater than or equal to this, we'd have our restrictions, wouldn't we? How do we get the thises? Yeah. So we can go second trace 0. Oopsies. Second trace 0, number 2. And I am currently coming over to this side here. Enter. And then I'm going to go below because it wants it on the right of that. So x is going to be less than negative 1.290994. Wait, I want to see if it turns into a fraction. So I'm going to go second mode. I'm going to put down my marker. I'm going to go second mode. Go away. Second mode. Boom. X. Enter. Boom. Math. Enter, enter. No. All right. Stays the same. We're back to here. Okay. We're good. We have that one. Now we need the other one. Second trace. 2. Left bound of the second one. Enter. Right bound of the second one. Enter, enter. 1.29. Are they always that nice? This one is that nice because it is symmetrical about the y-axis, because we have a vertex at 0 and negative 5. Why do we have a vertex at 0 and negative 5? Our equation is, oh, it's up there, 3x squared minus 5. If I wanted to put it in vertex form, which we did last year, it would be 3x plus 0 squared minus 5, wouldn't it? What's my vertex at? 0 and negative 5. Ooh. Ah. Life lessons. Okay, so we have our restrictions, right? We have our restrictions. Now you guys are going to solve it. So remember, your very first step is to always get the radical by itself, so if it's not, you have to. Does anything factor nicely? Pardon? So if you have it negative, you should have the complete opposite signs. Negative 2x squared plus 8x plus 21. Yeah, I like what's having it positive. Does it factor? The anger level just came out with quadratic formula. And remember, with the quadratic formula, you always have to reduce your radical if you can. So you couldn't just leave it like this. They'll always reduce the radical. I think it's just all you can break down to is 4. 4 and 58. So root 232. breaks down into 4 and 58. The 4 comes out and becomes a 2. So it's grade 10, remember? And at this point, we've done it so much this year that it's no longer grade 10. Okay. So remember, it's 3 or nothing, right? Has to come out of all 3 in the quadratic formula, or it can come out of none. We agree? So we can take a 2 out, so we get a 4, get a 1, get a 2,